Deep in the Bolivian Andes, a colossal volcano once thought to be dead is rising from its grave. Uturuncu, nicknamed the zombie volcano, hasn't erupted in over 250,000 years. Yet in recent decades, satellites have detected the ground beneath it swelling upward, as if something vast is stirring beneath the surface. The land itself is breathing, expanding, contracting, and rumbling with low, mysterious tremors that defy explanation. What could possibly be waking this long, silent giant? Scientists were stunned to discover that Uturuncu sits atop one of the largest magma reservoirs on Earth, a supervolcanic system capable of reshaping continents. Each year, the mountain rises by centimeters, a slow but steady signal of movement deep within the crust. It's as though molten rock and volatile gases, trapped for millennia, are pushing to break free. Some researchers call it the Andean Yellowstone, hinting at the unimaginable power it could unleash if it ever erupts again. Now, as seismic swarms increase and the Earth continues to bulge, one haunting question remains. Is South America's zombie volcano truly waking up? Let's find out. Don't forget to click on that subscribe button and like this video, as it's the best way to support this channel. Uturuncu's last eruption occurred roughly 250,000 years ago, during a period when vast sheets of ice still covered much of the northern hemisphere. Since then, the volcano's two distinct peaks, formed from ancient lava domes, have stood as silent witnesses to the ages. Unlike more famous neighbors, such as Chile's Lascar or Peru's Sabancaya, Uturuncu shows no visible crater or fresh lava flows. For all appearances, it is a mountain long dead, yet the region surrounding it tells a different story. Uturuncu sits atop the Altiplano-Puna volcanic complex, one of the most volcanically active and geologically complex regions on Earth. This massive plateau of magma, stretching across parts of Bolivia, Chile, and Argentina, is home to one of the planet's largest partially molten bodies, the Altiplano-Puna magmatic body. Deep below the surface, this enormous magma reservoir, spanning hundreds of kilometers, is still hot and restless. For decades, the true nature of this subterranean giant remained hidden. But beginning in the 1990s, satellite radar measurements detected something astonishing happening directly beneath Uturuncu. Between 1992 and 2006, data from interferometric synthetic aperture radar revealed that the ground around Uturuncu was rising at a rate of about 1 to 2 centimeters per year, a subtle yet unmistakable motion. Over time, the uplift pattern spread across an area of nearly 1,000 square kilometers, forming what scientists called a Sombrero pattern, a central uplift surrounded by a ring of subsidence. To visualize it, imagine a sombrero hat resting on the Earth's crust. The center of the hat is rising, while the outer rim sinks slightly. This peculiar pattern indicated that something deep below was pushing upward, something capable of deforming the crust across a vast area. At first, geologists feared this was a sign of an imminent eruption. A magma chamber expanding beneath a dormant volcano could signal magma movement toward the surface, a prelude to explosive activity. Yet, upon closer examination, the data suggested a slower, more complex process. Recent seismic imaging and geophysical surveys have begun to unravel the true cause of Uturuncu's awakening. Deep beneath the volcano lies a network of magma bodies, hydrothermal fluids, and volcanic gases that are migrating upward through cracks in the crust. The Altiplano-Puna magmatic body, located roughly 15 to 20 kilometers below the surface, acts as a massive heat source, a partially molten zone of magma and volatile gases. From this reservoir, fluids and molten rock rise into smaller pockets closer to the surface, building pressure over time. These intrusions do not necessarily indicate an eruption is coming soon, but they do suggest the volcano's internal plumbing is recharging. A 2025 study by researchers at Oxford University used over 1,700 local earthquakes to image this subsurface structure. Their findings revealed that the uplift and seismic activity are primarily caused by volatile-rich fluids, not magma alone, rising into the crust and accumulating in shallow reservoirs beneath Uturuncu. These gases, including carbon dioxide, sulfur dioxide, and water vapor, expand when heated, causing the crust to bulge. In essence, Uturuncu's heart is not beating faster because magma is racing upward. It's swelling from the buildup of heat and gases deep below. While no lava has erupted in millennia, Uturuncu is far from still. A constant background hum of micro-earthquakes ripples beneath its flanks. Fumaroles, small vents emitting steam and sulfurous gases, dot its surface, staining the rocks with vivid yellows and reds. Scientists have recorded increasing levels of CO2 and hydrogen sulfide emissions, suggesting ongoing degassing from deeper sources. During seismic monitoring campaigns, clusters of small quakes, known as seismic swarms, have been detected. These typically occur when fluids or gases migrate through cracks in the crust, fracturing the surrounding rock. Though these quakes are too weak to be felt by humans, they indicate a dynamic and shifting underground environment. In recent years, geodetic networks have continued to detect ground movement, alternating periods of uplift and deflation. This breathing of the earth, like slow inhalations and exhalations, implies pressure variations within the magmatic system. Combined, these signals point to a volcano that is very much alive beneath its seemingly frozen exterior. Understanding Uturuncu's behavior requires looking at the geological history of its surroundings. The Altiplano-Puna volcanic complex is home to some of the largest explosive eruptions in the last 10 million years. Events that blanketed the continent in ash and reshaped the Andean landscape. Nearby calderas, such as La Bacana and Cerro Galán, were sites of cataclysmic super-eruptions that expelled thousands of cubic kilometers of magma, rivaling the scale of Yellowstone's ancient blasts. The vast magma reservoir beneath Uturuncu is thought to be the fossil remnant of this supervolcanic system, still partially molten and capable of feeding smaller eruptions. This history adds weight to the question, can Uturuncu one day erupt again? Current evidence suggests that while magma is accumulating slowly, the system remains in a recharge phase, not an eruptive one. Still, history shows that such systems can awaken after tens or even hundreds of thousands of years of dormancy. If Uturuncu were to erupt again, what could happen? Given its geologic history, scientists believe it would most likely produce moderate-sized explosive eruptions, similar to Mount St. Helens in 1980, powerful but localized. Such an event could send ash clouds across the Altiplano, affecting regional air travel and nearby ecosystems, but it's unlikely to produce a global catastrophe. However, if deeper magmatic activity were to reawaken the vast Altiplano-Puna system beneath it, the story could change dramatically. A large-scale eruption from this region could rank among the most powerful on Earth, potentially altering climate patterns and affecting continents. Thankfully, no evidence currently points towards such a scenario. The magma body remains deep, and the gas pressure insufficient to fracture the crust to the surface. For now, Uturuncu's restlessness seems more a sign of geological adjustment than imminent disaster. Uturuncu stands today as both a mystery and a warning. It challenges our understanding of volcanic life cycles and forces us to reconsider what it means for a volcano to be dead. By studying Uturuncu, scientists gain insight into how supervolcanic systems evolve after their massive eruptions. They learn how the crust heals and reheats, and how deep magmatic reservoirs behave over geological timescales. This knowledge is crucial for forecasting volcanic hazards worldwide, especially in regions with similar long-dormant systems. As technology advances, researchers continue to watch Uturuncu with satellites, drones, and new seismic instruments. They hope to understand whether the ongoing uplift will continue, stabilize, or reverse. Early signs suggest that the deformation may fluctuate cyclically, rising for years, then slowing or subsiding, depending on the movement of fluids below. In the long term, Uturuncu may one day erupt again, though perhaps not in our lifetimes. Its story reminds humanity of the immense timescales on which our planet operates. What seems like dormancy to us is, in geological terms, merely a pause. Whether Uturuncu erupts in 10 years or 10,000, it will remain one of Earth's most important natural laboratories, a place where scientists can study the rebirth of a volcano in real time. And as the Andes continue to rise, so too does the mountain's quiet roar from below.